Welcome to the fourth section of the course called Creating a Server-Side Shopping API, where we will create a basic e-commerce API using Node.js, Express.js, and MongoDB. We will begin by setting up the connection to the database and posting orders to our database. Moving on, we will implement a delete endpoint for removing orders from our MongoDB database. Next, we will update existing products by reducing their stock count. Finally, we will make a few corrections and call all the endpoints we created using Postman. So let's get down to business. The primary goal for this video is to create an endpoint to post new orders to our database. However, before doing that, I will have to get you familiar with the existing code base that we need in order to get this project running, and also create the order and product models. Finally, when we've done that, we're ready to go on with our endpoint. So this is the project that we're going to be using to create our API. We have a server folder, and within it we have some common middleware like the Express static middleware for parsing JSON, logging, API calls to the console, course, and of course Helmet for protection through common attacks. Now, inside the error handling middleware, we have an error logger that logs the error to the console and then goes ahead and responds with internal server error to the caller. Inside the utilities folder, we have this async wrapper that wraps or async calls and delegates the handling of the error if an error occurs to the error handler that you saw a few seconds ago in the middleware folder. This is the server.js file. This is where we start the server. This is where we register the middleware, and this is also where we are going to import our controllers. We'll also use the port supplied by the environment to start the server. Now let's go on and open our MongoDB. This is Robo3D. We can see our database here. We have two collections, an orders collection and a products collection. This is what we need to create a very basic shopping API. Now if I right click on the products collection and go over and click on view documents, I've pre-filled the collection with 14 products. Now if we expand the first one, you can see we have the typical object ID, we have a name, a price, and an image URL. I've stored images for these products on Cloudinary, so we can use them on our front end without having to store the whole image somewhere else. Now I'm going to right click on this one, click on view document, copy the whole document, and I'm going to go and create an order. So right click on the orders collection, and then I'm going to click on to insert document. Now, let's say that an order can have multiple products, so it is wise to have an array of products instead of having just one product. Otherwise, we would have to insert multiple orders when someone orders multiple objects. So it is wise to use an array for this kind of application. But when ordering, we also need to have more information about who the person that created the order is. So I'm going to go ahead and under the products array, I'm going to create a new object called customer. In the customer object, we need to store all the information that the store needs in order to provide said individual with the order. So we need the first name, let's say the customer's name John, and last name, let's say his last name is Doe, and in the email address, I'm going to use something very generic. Then we need an address. The address usually consists of a street. Let's go with something very commonplace in programming online courses and call the street foobar. And we also need a number. I'm going to go with 42. And let's say that this current individual also has a phone number that we can contact. Awesome. I'm going to go ahead and click save. It seems that we have a JSON parsing issue. Right after the phone property, we've missed a column, and we're good to go. If we right click and click view documents, you can see that it has been assigned an object ID, and we also have exactly the information that we supplied. Using MongoDB directly is cool, but we have an API to build, so let's go back to our project and install Mongoose. Mongoose is a library, an ODM, that stands for Object Document Mapper, that we can use in order to communicate with MongoDB in the most efficient way possible. In order to use it, we will have to start a connection with MongoDB. So let's go on to our models directory, which is for now empty, and create an index.js file. That file will be responsible for initializing the database. So as you may have guessed, we will need to include it in our main server.js file. Let's start by requiring the Mongoose library. Then we will export a function whose goal will be to initialize a connection with a database and return a promise that resolves when said connection has been established. Now this line of code sets the promise object in the Mongoose library to the global promise. So we are going to use native promises. And now let's go ahead and connect. This is the default URL. And in order to avoid a specific depreciation warning, we also need to provide this flag. Now we also need to listen for two events, you may say two callbacks. The first one is an error callback. So this one is going to be called whenever something goes wrong. So mongoose.connection.onError, and we reject the promise. We also need to resolve the promise once the connection has been established. So once open, we resolve, and we pass on the whole Mongoose library. So whoever wants to use the Mongoose library has to go through this file in order to know for sure that the connection has been established. So now that we have a solid way to connect to the database, let's go on and start creating the actual models. We will begin with the product model. So create a product.js file in the models folder, and in order to define a model, we need to include the Mongoose library again and use the model method of the Mongoose library. Now model accepts 3 arguments. The first 2 are required, the third one is optional. The first one is the name of the model, of course. The second one is a schema object where we'll define the properties, and the third one is the name, the actual name that we've used for the collection in the actual database. Let's create the first property. It's of course the name of the product. It's of type string. It is required, and I'm also going to use the term property here to remove white space from the beginning and end of the string every time we save it. The price is of course a number, and it is required. Every product must have a price. We don't need to use another property here, so let's move on. We're gonna go now and create the image URL. For the purpose of this course, I've stored some images in Cloudinary. That way we can quickly import those images in our frontend application in the next section. The images are not required for a product, and since this is a URL, let's also trim it. Finally, I'm going to define a property called available, which is the number of remaining products in stock. So this is again a number, of course, it is required, and let's set its default value to 0. Cool. Now moving on, I'm going to create a second file, name it order.js, and this is going to be the order model. Again, we will have to import the Mongoose library and use the mongoose.model method to create the order model. In the schema definition for this file, we have something different in comparison to the product model. We have an array, so we need to set it explicitly that this is an array in the type, and it's also required. You can't have an order without having some products in it. And we also have an object, so this is a nested object, and this is exactly what we do in order to define it. So we have a customer, and the customer has some properties. Very intuitive way of handling things, exactly how JavaScript works. This is one of the advantages that MongoDB and, in extension, Mongoose have. We have the first name, the last name, all of them are strings. They are required. We could also use trim here, but let's keep things simple. We have an email address of type string that is required as well. We have the phone. Notice that we don't use a password. We're going to assume that you can order as a guest in this application and leave the authentication part to keep this API as simple and realistic as possible. And in the address field, again, we have a nested object. So the address consists of two properties: the street property, that is a string and it is required, and the number property, that is a number and is required. Now, in order to really define those models, we have to call the actual code that resides in those files. And the best place to do that is in our index.js file. Inside the models folder, we don't need to do anything other than simply requiring those objects. We have successfully prepared our application, so let's go ahead and actually create those endpoints. Let's go ahead and create a controller. We're going to call it orders-controller.js, and this is how you define a controller using Express.js. First, we need to obviously import the Express library. So let's require it. Since we're going to define Express endpoints, we're also going to need the async wrapper so that we can use promises and async await inside our Express handlers without having to worry about errors. All errors that happen within those endpoints, within those callbacks, will be delegated to our error handling middleware. Using the router is very important because we want to group the following endpoints under a single API path. And since this is the orders controller, we're obviously going to need the orders model. Any call to the MongoDB database is gonna go through the order model. And we may need to use object ID. Object ID is part of the Mongoose library. So let's include it as well. And now that we have a router, let's define a get method in it. This is how you use the async wrapper. You wrap the actual callback that happens to be an async method, and by doing so, any promise rejection or error that gets thrown inside the async wrapper will be caught by the async wrapper and passed over to the error handling middleware. Now, the get method will be implemented in one of the next videos. We are here for the post method so that we will be able to create new orders. Again, we use the async wrapper in the same fashion. And in here, we need to grab the order from inside the request body and pass it over to the order model constructor. If something is missing, this is going to throw an error. Now, if nothing's missing, we can save and await the operation, and then go on and return a status of 200 OK. That's it for the post endpoint.